is that at any split second, okay, let's see, this is sulfur and this is sulfur, so that's 16 and 16 and 12. There's something like 44 and 6. There's something like 38 electrons moving around in here. At any split moment in time, if for some reason there are more electrons on the right side of this molecule than the left side, it will take a slightly negative charge. Now, the fact that electrons are moving around the molecule trillions of times in a second means that we are guaranteed for this to happen. It is guaranteed that if this molecule does not have a charge on it, there will be more electrons on one side than on another side in any split second, making that side negative and this side positive. And that's the trick, because now if something becomes slightly negative and something else becomes slightly positive, it is going to induce a charge in all the molecules around it. So now if I were to look at this molecule and this one, both of these molecules, notice this charge. That positive charge gets felt here. It pushes a positive charge to this side and it brings a negative side over here. This negative will do the same thing. It will bring a positive over and it pushes the negatives over to that side. Now, these molecules do not notice this one. So let's take care of it. Make it small again. However, these molecules will notice over here. This one now notices the negative charge, becomes positive here. It notices positive charge, it's going to become negative. These molecules will begin to notice this one. Maybe we can put it in green. That positive charge induces this negative will induce this. So, what happens is as soon as one molecule gets a charge, like a shock wave, it's going to send charges out throughout all the molecules around it. And then, there's going to be an attraction, well, let's do it in red. There's going to be attraction between all the negatives and the positives. Now they become attracted. Now they become attracted to each other. This is an intermolecular force now. It was never there to start with, but it was induced. And if I want to group these, it's going to get induced, and now what's going to happen is this spreads throughout the entire liquid or solid, whatever it's in. And this is called London dispersion. Whenever you get something that induces charges, and then those charges attract to themselves, that's London dispersion.